Hello. In this session, we are going to look at how to use graphs to solve equations. So let's start with an example. Right, suppose we have two equations like this, with the two unknowns x and y. So we are looking at a set of simultaneous equations, and we need to solve these two equations. And we have learned how to do that in a previous session. We can subtract the two equations, for example, and get rid of either the x or the y. Now, we can also find the answer by using a graph. Let's see how to do that. Right, so, but just for a start, the idea is quite simple. We just need to plot a graph for each of the equation and then find the point of intersection, and that will tell us the answer. Okay, let's start. Now I'm going to call this equation 1 and equation 2, right? And to plot a graph, I need to make a table of some numbers. So let's do that. Now for the first equation 1, let's make a table of x and y. Now we really only need 2 points for a straight line. Okay, so let's see. Let me use -2 and 2 for the x. Then when x is -2, in the first equation you'll find -1 for y, and when x is 2, 2 plus 1 is 3. So that's one table. Okay, let me just start by plotting the graph for equation 1. X-axis, y-axis, origin. So x goes from -2 to 2. So -1, -2, 1, 2. And y goes from -1 to 3. So that's -1. That's 1, 2, and 3. Alright, so the first point is -1, -2. So -2 minus 1, -2 minus 1 is there. That's one point. And the next point is 2 and 3. 2 and 3. There. We have 2 points. We know that it's a straight line, so we can join them with a straight line. There. That's our line number 1. Call that 1. Now let's plot the second graph. X and y. So let's put x as -2 and 2. Then when x is -2, minus of -2 is 2. 2 plus 2 is 4. So y is 4. When x is 2, we have -2 plus 2, which is 0. Alright, let's plot this. First point is minus 2, 4. So minus 2. So y goes up to 4, so that's 1, 2, 3, 4. It's up there. So the first point is minus 2 and 4. Minus 2 and 4. That's one point. The next point is 2 and 0. So 2 and 0 is here. We have the 2 points and we can join with a straight line. So there we have our 2 lines. Now, in order to find the solution to these simultaneous equations, all we need to do is to look at the graph and look for the point where they intersect, where they cross each other. So that's the point there, alright? And now let's see, the coordinates, the x value of that point is there. So let's say it's about half. And the y value is there. That's it goes 1, 2, 3. It's in between 1 and 2. So let me say it's 1.5. Okay, if you have plotted this carefully on a graph paper, you can get a more accurate answer. So for my rough drawing, I'm just going to write down some rough value. The important thing here is to understand the idea. So if these are the x and y values of the point where the two straight lines intersect, alright, then these are the answers to these two equations. Now let me write down the answer. So the answer is x equals to half and y equals to 1.5. So it means that if I substitute these values, half for x and 1.5 for y, into each equation, then the left side will be equal to the right side. So let's try that. If x is half, the right side of that equation is half plus 1, which is 1.5. And y here is 1.5, so the left side is 1.5. So therefore 1.5 is equal to 1.5. So it works. Now, but do you wonder why it works? Why? Can we just look at the points of intersection and know that that gives the answer? The reason is this. Now, if we go back to this table, this is the table that comes from equation 1. Now, when I make this table, right, I put in some value of x and I calculated the value of y using that equation. So that means that this set of numbers, minus 2 and minus 1, if I put them back into the equation, the left side and the right side will be equal. So this means that this is a set of x and y that satisfies this equation. Okay, that's how we describe x and y. If they can make the left and right side of the equation equal, we say that it satisfies the equation. So in a way, it is like these two numbers is a solution to that equation. Okay, because if you substitute -2 and -1 into that, the equation becomes true. Left side equals to right side. But it's just that if for this equation alone, we can also put, say, 2 and 3 into the equation, and left side will again be equal to right side. So if we have just one equation, there can be many solutions. You can put in many pairs of x and y into the equation and it will be satisfied. And that's exactly why we have a graph like that. What it really means here is, if you look at the -2 and -1, that was this point. 2 and 3 was that point. Now, if you look at it in the reverse, okay, if I look at this graph and I pick a point in the graph, like let's say that point, -2 and -1, then the x and y values of that point will satisfy that equation. So that we already know, because we made this point, -2 and -1, from the equation. Okay, so we already know that. And the same for the point 2 and 3. Okay, it came from here. So if I pick that point, I know that the x and the y will satisfy this equation. It will make the left side equal to the right side. That means it's a solution to that equation. But let's take a slight jump in the imagination. Let's pick a different point, just any point along the graph. Let's say that point. Now if you try it out carefully on a piece of graph paper, you'll find that the x and the y value of any point that you pick on the line will also satisfy that equation. And the reason is quite simple, because this equation, if we say that the graph of this equation is a straight line, it simply means that if you make a table of these values like that, where you calculate the y from the x value and you plot that point must be always on the line. So you can turn this idea around and say that if I have a point on that line, then that point must have come from that equation. Alright, so that means that if I pick any point, then the x and the y must satisfy that equation. Otherwise, that point should not be on the line. Alright, so now that we know that for any point on this line, the x and the y values would satisfy this equation, then we can say the same of the next equation. So this equation 2 gives that graph. So therefore, if I pick any point on this line, the x and y value must satisfy that equation. In other words, that x and y value must be a solution to this equation. Okay? So far so good. So that means that each graph is the points along each graph represent a solution to the equation where it comes from. Now let's go to the point of intersection. That's the point of intersection, is the point where the two straight lines cross and cut each other. Now there is something special about this point. The point of intersection lies on line number 2. Let me label that. Okay. The point of intersection also lies on line number 1. Therefore, the points of intersection lies on both lines. It lies on both line number 1 and number 2. And therefore, the x and y values of the point of intersection must satisfy both equations. And therefore, the x and y values will be the solution to these two simultaneous equations. So that is the reason. That is the reason why we can use the point of intersection to find the answer to a set of two simultaneous equations. And we call this the graphical method of finding the answer to the equations. The graphical method to solve the equations. Okay, now that seems like a lot of trouble to find the answer to these two equations when we know that there are simpler ways. We have learned them in the session on simultaneous equation. We can just do it by adding or subtracting both equations to get the answer. So there does not seem to be much reason to go through all this trouble and time just to find the answer. Now, but there is a reason for learning this method. It is because we can use it for equations that are more complicated, that are more difficult to solve, and maybe that can't even be solved using a simple algebra. So let's look at a slightly more difficult example. Okay. So now I have two equations again, and as you can see, they are slightly more complicated because I have an x squared in the first equation. It is a quadratic equation. So that makes it more complicated than a simple straight line. Now for this example, we might be able to solve it using algebra. For example, you may try substituting x plus 1 into the y there, and then you might try to simplify that, or maybe factorize it. Alright, you can try out the methods for quadratic equation and you might be able to find the answer, or you might not. Right, for some quadratic equations you cannot just do it by factorization, but you can always use the quadratic equation formula to find the answer. Now, but in this case, I'm going to show how we can also use the graphical method to find the answer. Alright, now if you remember from the example before this, the way is to plot the two graphs and find the points of intersection. So let's try it for these two equations. Once again, I call that equation 1 and call that equation 2. And I need to make a table of values. So x and y. Alright, so let's go for minus 3, minus 2, minus 1, 0, 1, 2, 3. Right, so that's minus 3 would be 9, plus minus 3 and minus 1, so that will be 5. Minus 2 is 4, minus 2 minus 1 is 1, minus 1 is 1, minus 1 is 0, and minus 1 is minus 1. When x is 0, I have minus 1 again. Okay, and so on. It goes to 1 and goes to 5. So I'll just leave out the 3. So that's my equation 1, and equation 2 gives another table. Okay, for the x, I'm just going to use the same set of numbers. Minus 3, minus 2, minus 1, 0, 1, 2. So, the equation is x plus 1, so I just need to add 1 to each of these. So that's minus 2, minus 1, 0, 1, 2, and 3. There, we have both tables now, and we are ready to plot the graphs. Okay. That's the graph, and the x goes from minus 3 to minus 2. 1, 2, minus 1, minus 2, minus 3. That's x. And the y goes from, the lowest is minus 2 to 5. Okay, so it goes 1, 2, 3, 4, 5. The lowest it goes is to minus 2. So there we have our axis. Let's plot the graphs. First point is minus 5, minus 3, 5. Minus 3, 5 is up there. Next point is minus 2, 1. So minus 2 and a 1 there. That's 1. Minus 1, minus 1. Minus 1, minus 1 is there. Okay, and we keep going. There. There. So we start with points. Okay, it should be 0, minus 1 is there, there, and there. Okay, so let me draw a curve. So it roughly looks like that. Okay, not a very good curve, but we just want to see the main idea. So let's do the next graph. Okay, but before I actually do that, let me just notice that that's actually a straight line. So in fact, we only need 2 points. So let me take the 2 endpoints. Minus 3, 2. Minus 3 minus 2 is there. Okay, and 2, 3 is the next point. So 2, 3 is there. There we have the 2 points, and we can just join them with a straight line. Something like that. There, that's our straight line. So, if you remember the idea from before, we need to find the points of intersection. And here they are. That's one point. That's another point. We have 2 points of intersection. Okay. Now, that means that we are going to have 2 sets of answers. So that is not too surprising, because we have learned about quadratic equations, and we know that quadratic equations could have 2 answers. So let me estimate the answers from this graph. So let me call this point A and point B. Okay, so for point A, the x value is between -1 and -2. So let me just say it's roughly -1.5. And the y value is about 0. Okay, I'll just call that 0. And for B, the x value is between 1 and 2, so maybe about 1.2. The y value is close to that. Maybe it's sort of around 2. So that's the two sets of values. Alright? Either it can be, you can have x equal to -1.5 and y equal to 0, or you can have x equals to 1.2 and y equals to 2. So that's the two sets of answers. And that means that by saying that this is a set of answers, saying that x equals to -1.5 and y equal to 0 is an answer, that means that if we substitute the first pair of numbers into each equation, it will be satisfied. The left side will be equal to the right side. And likewise, for the next set of solutions, x is 1.2 and y is 2. If we substitute these two numbers for x and y in each equation, it will be satisfied. Okay, but again, like the graph before, because you're plotting it on the graph, you can be very careful, do it properly on the graph paper, and when you find the point of intersection, your answer can be quite accurate. But even then, because we are trying to find a point on the graph by reading it off from a scale on the graph, the little squares on the graph, you often have to estimate the decimal place, especially if the x value is in between two lines on the graph. Now what that means is that the answers that you get from the graph, it may only be approximate. So if you actually substitute these numbers into the equation, it may not be satisfied exactly. So for example, left side might be nearly equal to the right side, but they may not exactly be equal. So that's one of the things about using graphical methods. You can use it to solve any equations, no matter how complicated. You can try and use the graphical method, and it would often work, but the thing is that it is not exactly accurate. The answer tends to be a little bit approximate. Okay, right. We are going to move on to another topic now. I'm going to talk about inequalities. inequalities, as the name might suggest, means not equal. In as in not, equalities as in equal. So just as a very simple example, 5 and 2, they're not equal. Okay, now for the topic of inequality, we are interested in a special type of inequalities. We are interested to know which, not only that the two numbers are equal, but is one bigger or smaller than the other. So for example, in this case, 5 is bigger than 2. And if 5 is bigger than 2, we represent this relation by that symbol. So this symbol means that 5 is bigger than 2 or greater than 2. Okay? So for another example, if I have a 4 here and a 7 here, so this I can write that symbol, which means that 4 is less than 7. So we are interested in this kind of relation as well. So because of this, we say that 5 is greater than 2, 4 is less than 7. We think of this as a greater than sign and a less than sign, and we think of this as a type of inequality. Now what we are going to learn is how to deal with inequalities in algebra, how to do questions that involves inequalities and algebra. Now let me start by making a simple example. Let me just look at this. X more than 1. Okay, what does that mean? Now I have algebra here. I have x. X is a symbol that represents some number. Okay, so that's what algebra is about. We represent numbers by the symbols. I have an inequality, the greater than sign, and I have the number 1 down there. So what this inequality means, really, is that x is a number that is greater than 1. So in other words, what I've just done is I have looked at this equation, I've looked at the meaning of each symbol. The x is a letter that represents a number, the greater than sign, and the number 1. And I've simply read out the meaning of each of these letter, symbol, number in words. So x is a number that is greater than 1. So that's the easy way to do mathematics. Right? We can always understand the mathematics the moment we read out the symbols in words. Okay, so now that we have read out the meaning of this, x is a number that is greater than 1, the next thing we want to think about is, so what is x? So that's what we do in algebra. If we have an equation with x inside, we need to solve it to find out what is x. Okay, so, and we are used to having a question like maybe 2x plus 1 equals to 3, and then we can solve for the x and get a definite answer. But in this case, is there a definite answer for x? If x is a number that is greater than 1, then what is x? Okay, let's make some guesses. Let's try some numbers for x and see whether it can be a solution or some kind of an answer to this. Okay, we wouldn't call this an equation because there's actually no equal sign. So instead of calling it an equation, this kind of relationship is called an inequality. So it's like equation, but it is a different kind of thing. We call it an inequality. Alright, so let's try and make a guess of a number x. Just pick a number like 3. So we ask the question, okay, can x be 3? For example, can x be 3? Well, x is a number that is greater than 1. And if x is 3, is it greater than 1? Yes, of course, 3 is greater than 1. So therefore, the answer is yes. X can be 3. Can x be something else? Right. Can x be, say, 0? So x is a number that's greater than 1. Is 0 a number that's greater than 1? No. It is not. Now you're beginning to get the idea. Okay, let's just guess another number like maybe 6. Okay, so can x be 6? Well, 6 is greater than 1, so yes, x can be 6. Right, so we've just found that 3 and 6 can both be x. And in fact, since x is just a number that's bigger than 1, any number that's bigger than 1 can be x. So that means that if we are thinking of finding some kind of an answer to this inequality, if we want to try and find out what number x can really be, there can really be many possible answers. X can be 2, can be 3, can be 4, can be 5, can be 6, can be 1.5, can be 1.3, can be 7.8, just any number you can imagine. So there are many solutions. In fact, there are so many that you can't count. It can be any number more than 1. There is an infinite number of possible solutions. So that might sound quite useless, quite meaningless. If there is an infinite number of solutions and if x can be any of these numbers, then doesn't it mean that there is no answer? That x cannot be any particular answer? And that there's nothing we can give as the answer? Well, not entirely, because we do know, for example, that x can't be 0. We know that x has to be more than 1, so x cannot be 1. X cannot be any numbers that are less than 1. X cannot be half. X cannot be -1. X cannot be -10. So there are also many numbers that x cannot be. So x cannot just be any number. X has to be numbers that are more than 1. So in that sense, that's how we understand this inequality, that x are numbers that are more than 1. So in fact, if you like, there is not much more that we can describe about x except that it's a number that is more than 1. And that is a kind of answer. Sounds pretty trivial, we are not saying anything new. But in this case, that is really all we can understand about it. Okay, now to see the point of all these talks, what we need to do is to look at something slightly more complicated. Okay, now let me do something like this. X plus 1 is more than 3. What if I have this inequality? What can I say about the x? Okay, I'll have x plus 1 is more than 3. So x is a number, okay, which when you add 1, the answer must be more than 3. So that's how we could read this out in words. X is a number which, when you add 1, has an answer that has to be greater than 3. Now that's quite a mouthful. That's a lot of words to say, and it can be a little bit confusing. So what can X be? Alright, we can go through this and we can start guessing some numbers, and after some trial and error, we could have a better understanding of what are the possible values X can really have. Now that's one way to do it. There is a more standard way, a more systematic way. And the idea is to turn this, is to somehow rearrange this as like the kind of things we do in algebra. We can rearrange equations so that we have only x on one side. Now, does that sound familiar? In algebra, if we have an equation involving x, if we can somehow rearrange that until we have just x on one side and all the other numbers on the other side, then we have more or less solved the equation, because we can just calculate the numbers on the other side and get the answer. So in this case, can I somehow rearrange that so that we have just x on one side? Let's try. Okay, let's look at this inequality. I have a number x. When I add 1, it has to be more than 3. Now, we can actually apply the same idea as equations in algebra. If you remember, when you have an equation with a right hand side and left hand side, so some symbol on the right side equals to some numbers on the left side, then if you add the same numbers to both sides, the left and the right side must still be equal. Or if you subtract the same numbers from both left and right side, the two sides must again be equal. So as long as you do the same thing to both sides, the idea is that the both sides will still be equal. Now, can we apply this idea here? If I subtract the same numbers from both sides, is this still true? Is the left side still greater than 3? Because I don't have an equal sign there, okay? I have a bigger than sign. That seems a bit, that is something which is a little bit more complicated than just a simple, than just an equal sign. Now, in order to understand whether it is okay for me to subtract the same number from both sides, because I would really like to subtract the 1 from that side, because if I subtract the 1 from the left side, the 1 is gone and I just have the x. So if I can subtract 1 from both sides, that will help, right? So in order to try to understand whether we can do this kind of thing, let's go back to that first inequality that I wrote down, that 5 is greater than 2. If I look at this 5 is greater than 2, can I subtract 1 from both sides? If I do that, will the left side still be greater than the right side? So let me just try that. If I subtract a 1 from the 5 and a 1 from the 2, what do I get? Okay, if I subtract a 1 from the 5, I get 4. If I subtract a 1 from the 2, I get 1. And 4 is still greater than 1. So the symbol, the greater than sign, we can keep. Alright, it's still correct. It's still greater than. So from this, from what we have done here, it looks like it is okay, and in fact it is. Let's do it to this. Now let me subtract the 1 from the two sides. If I take away 1 from there and there, then the left side must still be greater than the right side. And on the left side, I'll just get x, only x remains. And on the right side, I have 2. Now, it's simpler now. Alright, I just have x is greater than 2. Now that's easier to understand than x plus 1 is greater than 3, definitely. Right? It means that x is a number that is greater than 2. So any number that's greater than 2 can satisfy this inequality, will make this relationship true. Okay, any number that is greater than 2 will make this correct. So instead of saying that x is a number that when you add 1 gives an answer that is greater than 3, which is long and complicated, all I need is to subtract the 1 and I get this much simpler thing, this much simpler inequality that just says that x is greater than 2. So in a sense, this x is greater than 2 is a kind of solution to this x plus 1 is greater than 3. So, and in fact, that's what we mean, or what we need to do when we do questions in inequalities, when we need to kind of solve inequalities. We simply solve it using more or less the same ideas from solving equations in algebra, by doing the same things to both sides and trying to get just the x on one side and all other numbers to the other side. Okay, so while we are here, let me just mention one thing. Now I've said that you can do the same kind of things that you do to equations. That is not always true. Now, you can subtract the same number from both sides of an inequality. You can add the same numbers to both sides of an inequality. You can even multiply the same number to both sides of the inequality. But there's a catch here. You can only multiply positive numbers to both sides of the inequality. You cannot multiply negative numbers. Why not? So let's take a look at this 5 is greater than 2 again. Okay, let's look at 5 is greater than 2. Now I'm going to try and multiply minus 1 to both sides. Okay? I'm going to multiply this by minus 1 and multiply that side by minus 1. Right? What do I get? Minus 1 times 5 is minus 5. Minus 1 times 2 is minus 2. So after multiplying by minus 1, can I still say that this greater than relation is true? Can I say that minus 5 is still greater than minus 2? Minus 5 and minus 2. Okay. You can't, because minus 5 is less than minus 2. Now negative numbers are always slightly more tricky to compare, to know whether one is bigger than the other. So if you're still struggling with negative numbers, let me suggest one way to think about it. I tend to think about it as points on a number line. So I might have 0, 1, 2. So I can represent numbers by points on the number line. So on the other side I will have minus 1, minus 2, minus 3, minus 4, minus 5. If that's minus 2, minus 5 is further to the left. So the idea of thinking about a number line is that any number to the right, further to the right, is greater than numbers that are on the left. So 2 is greater than 1, but 1 is less than 2. So minus 2 is greater than 5, but minus 5 is less than minus 2. So if minus 5 is to the left of minus 2, that means minus 5 is less than minus 2. So minus 5 is less than minus 2, right? But what we see here in this inequality is that this inequality says that minus 5 is greater than minus 2. So therefore, this is wrong. And therefore, if we multiply by a negative number, the inequality is not true anymore. Now, but that doesn't mean that we are not allowed to multiply by minus 1. It just means that we have to change the rules for this special case. Okay? It means that if I multiply by minus 1, I must flip the inequality. That means if I have a greater than symbol there, then when I multiply by minus 1, I have to change it to less than. Okay, then it will be correct, because then minus 5 is indeed less than minus 2. So remember this, you can add or subtract the same numbers to both sides of an inequality. You can multiply by a positive number both sides of the inequality. But when you multiply the two sides of an inequality by a negative number, so it doesn't have to be just minus 1, it can be minus 2 and minus anything. If you multiply the two sides by a negative number, you have to flip the inequality. That means greater than becomes less than becomes greater than. Okay, we will stop here now.